this session, we'll discuss about a linked list. A linked list, it is a linear data structure similar to arrays. It is a collection of nodes that are linked with each other. To implement the linked list, we'll use classes in Python. It consists of nodes and nodes have two elements, data and a reference to another node. In this diagram, you can see this is one node, data 200, reference, it is a address which will point to the next node. This is also a one more node. This is also one more node. We have three nodes. In first node we have data 200. In second node we have data 300. In third node we have data 400. The first node head will point to the first node, and the first node reference is address which points to the second node. Second node reference points to the third node. After third node, we don't have any other nodes. So reference is a null. It points to nothing. This is an example for singly linked list. This is the explanation. Our first node is where head points. We can access all the elements by using head. How to access we'll see in the program. Creating a linked list. In the linked list class, we will use the node class to create a linked list. The class includes the following methods. Init method, it is used to initialize the linked list with empty head. Insert at begin, inserts a node at the beginning of the linked list. Insert after, inserts a node after the given node of the linked list. Insert at the end, inserts a node at the end of the linked list. A remove node, deletes a node by taking a data as an argument. It traverses the linked list and deletes the node if a match is found. Size of returns the current size of the linked list. That means how many elements are present in the linked list. It gives size. Print the items of linked list. How it will print? It has to traverse the linked list and prints the data of each node except the last node. These are all the methods available in the class. We will see the code snippets for each and every method one by one. We'll discuss about insert at begin, insert after. In next session, we'll see the remaining methods. Here we will discuss how to create a node class. Here this is one node. This is another node. This is another node. How to create it. This is the code for creation of the node. Class node initialization with self comma data, self dot data equal to data, self dot next equal to none. In this code we have defined a init function to initialize the node with the data passed as an argument and a reference with none. Here we have only one node. Whenever we create a node, that means it is a single node, and for that reason we have a reference equal to none. It refers to nothing. Now we'll see insertion at beginning. In this picture we have nodes 21, this one, another node 31, another node 12. This is a original linked list and head points to this one. So if you want to insert a new node at beginning of the linked list, what we will have to do? We will have to point the head node to the new node and the new node reference to the original node first element. That means this one. So we have to remove head node to the first element and point to the new node. New node reference pointer will be given to the original node first element. So this is a program. Define a node in the linked list. This is a class node definition. Self dot next none as usual. Function to insert a new node at the beginning of the list. This is a function. Insert at the begin. For this function, parameters head comma x. What is the new node? New node is equal to node of x. Whatever the data passed here, with that new node will be created. New node dot next equal to head. Return new node. This is the code for insertion of the new node at the beginning. Function to print the contents of the linked list. This is a print list which will take the parameter head, current pointer. We need to take one more reference pointer like current equal to head, while current is not none. If the current is not none means it is having linked list is having some items in the list. Print current data. We need to give space. If current dot next is not none, we are giving some arrow kind of like this. Again, we are giving some space. If current dot next means whenever the traversion happens, if the reference is not none, that means it is pointing to some other element. If it is none means it points to nothing. So the loop continues till reference pointer is not none. Okay. Till that time it prints the items in the linked list. Here the main program, if name equal to main, that means whatever the code present here, it it run and print the data. We are creating the linked list, initial original linked list with the three element 21, 31, 12. 21, 31, 12. How to create head equal to node 21, the first node, head dot next, the second node, node 31, this one, head dot next, node 12, this one. This is a this is the code snippet. It is a hard coded. Initially, we'll have to understand like this. You need not to use hard coded. Then once the data linked list, original linked list is created, we are inserting a new node. What is the value? The new value is 28. That means x equal to 28. The data we are passing to the function. Head equal to insert at begin. We are passing head pointer comma x new data. So this particular function here, head pointer x new data. So that's what we understood. New node is equal to node x. New node will be created. New node dot next equal to head. Return new node. So new node will be the first element in the modified linked list. So after that we are printing the updated list. Print list head. Print list is a function which is taking the parameter as head. Again the print list code is here. This one we understood, right? This one till this portion. Okay. Now we'll run this particular code and we'll see in Visual Studio Code. Here we'll paste the code. So what is the original linked list? This one 21, 31, 12. And after that we are inserting new node at the beginning of the linked list. So modified linked list should come as 28 after the 21, 31, 12. We'll save, we'll run. Yeah, you can see here the new modified linked list 28 inserted at the beginning of the linked list 28, 21, 31, 12. If you see the diagram 28, this is the first one, after that 21, then 31, then 12. This one is correct. Now we will see insert a node after a given node in the linked list. In this picture, head points to the first node 21. Again, first node reference is 31. Again, second node reference is 12. This is the original one. What we are doing here, after 31, we wanted to add new node 18. So that means what are the operation? We have to disconnect 31 to 12. We have to connect 31 to 18. This 31 data node is a given node. After that, we need to insert 18. Okay. So Python program to insert a node after a given node. Definition of a linked list node. Like previous, class node, constructor to initialize the code, definite self data, self dot data data, self dot next equal to none. Function to insert a new node after a given node. This is a function. What this function is taking parameter head key new data. Head one parameter, key another parameter, new data another parameter. So we need to traverse and we need to check in this linked list, complete linked list. We need to traverse from beginning to till end. We need to check the key. Key is a given node here. If the key found, we need to perform the actions. We need to disconnect the node address in the given node, and from given node we need to point to new node. From new node to from new node from new node we need to connect to the given node next node, like that. From 31 to 18 we need to connect. Before to that, we need to deconnect. That means we need to change the address here from 31 to 18, from 18 to 12, because the references are addresses. Okay, these are the operations we need to perform. See the same thing. We need to traverse from beginning. We have taken a reference pointer as a current curr equal to head, because head is at the beginning. Then we need to iterate over linked list to find the key. If key is found, then only we need to insert the new node after a given node. This one. If key found. If key is not found, the program has to print saying that required key not found. We cannot insert the new node in the linked list. That's what message. If here is the code, while current is not none, that means if it is not none, we have some elements. If current data double equal to key, whenever that loop is traversing from beginning to end, whenever it finds current data equal to key, key is the required value, given node data, whatever the given node data in the program. If it double equals, then we need to break. That means we have achieved the functionality here. Otherwise, it will traverse till it ends. Okay, till end it is not found, then it has to say the key not found. If it finds, it has to come out. If current becomes none, means given key is not found in the list. If current is none, print node not found. Return the head of the original link. Return head. Allocate new node and make the element to be inserted. When it allocate new node, if the current data matches to key, then it comes out and it inserts a new node here. New node is equal to node of new data. This one. Set the next pointer of new node to the next pointer of a given node. That means new node dot next equal to current dot next. Okay, that means new node dot next equal to current dot next. If you see this diagram, whenever the key finds new node dot x, that means this one becomes a current node. Then current dot next, this one. New node dot next is equal to current dot next. Okay. Then current dot next is equal to new node. That means current dot next, this one, to new node. New node dot next equal to current dot next. It's a deselecting and mapping. Return the head of the modified linked list. Once everything is done, we need to return head. Then function to print the linked list. Print list node. While node is not none, print node data end. Till not none, it prints the node data. Node equal to node dot next. When node is none, means the last element, right? So till that time it prints. This is the driver code for creation of the our main code. Create a linked list like this 21 31 12. This is a original list. Head equal to node 21. Head dot next node 31. Second element. Head dot next node 12. Print original linked list. Print list head. Key. Insert node after key. Key equal to 2. New data equal to 18. Insert a new node with the data 18 after the node having data 31. This is a 31 actually. Okay. Key value 31. After 31, new data has to be inserted. This is the function. Insert after we are passing head key. This is the value 31 and new data 18 here. Print the link once this particular function performed. We need to print the linked list after insertion. So we'll run this code and see. This is the original linked list 21 31 12. In this program, we are inserting the new node value 18 after 31. That means we'll have to get 21 31 after that 18. This is a modified linked list, then 12. This is the modified. Okay, we'll run this program and we'll see. Yeah, this is the complete code. File save, run. Yeah, original linked list 21 31 12. Linked list after insertion 21 31 18 12. 21 31 18 12. This is correct. Okay, that's all for this session. We'll discuss remaining methods in next session.